All right, what's with that video? Hold on. Okay, hello, y'all. I don't know what that was. My virtual background, I thought it would be behind us, but it's not. Welcome back to class. So we are going to be starting chapter 8, and these are probability distributions. We've already done a lot with distributions, so we're going to continue on with probability and distributions. Of course, you can use your calculator always. The first one is just a review. It's an example of a probability distribution. And a probability distribution gives, well, I guess I should get over there, gives possible values and the associated probabilities. So possible values of the variable, a random variable, and associated probabilities. In other words, it shows you the sample space and what's a probability of each one of those outcomes. So we're going to list all possible outcomes, and this is called our sample space. Now, this is a review of what we did. I told you in this unit we were going to get to where we were using formulas and didn't have to do all this, because we realized if we're going to write out everything for a coin toss, it's going to get really big really fast. Okay, so anyway, this is a distribution model. Remember on the last test, sometimes the word model got us confused and we were like, what do they mean by a model? A model simply means it's showing you everything that could happen. So we know the probability of a head or a tail is 1/2. Then when we do it again, we know that it's 1/2, 1/2, 1/2, 1/2, and so on. Head, tail, head. Obviously, we're not going to write a whole bunch of these out because they get big really fast, right? But this shows us head, 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 then head, head, tail. And here we've got head, tail, head, head, tail, tail. Then down here we have tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. Okay, so this right here is your sample space. Okay, so what we do is first we find our sample space. What are all the possible outcomes that we could have? This is every which way that we could flip a coin 3 times. Second, we make a summary table. So X is the number of tails obtained. So again, it's important to look at what they want us to find. They want us to find tails, and we're going to make 0 the value for all tails, 1 for 2 tails, 2 for 1 tail, and 3 for no tails. Okay, so we look up how many, well, first of all, how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. So a 0 is all tails. How many ways did we get all tails? 1 way. So that's 1 out of 8. How many ways did we get 2 tails? So let's put that in a different color. So 2 tails, right? Or you could call it 1 head. We're going to call it 2 tails. So there's 1, 2, 3. So 3 out of 8 had 2 tails. Then we wanted 1 tail, right? How many ways do we get 1 tail? 1, 2, 3. So that also was 3 out of 8. That was 3 tails. And this is going to be 0 tails. And you could see that that only happened, 0 tails happened right there. And that was 1 out of 8. And if we go back here, there's where we had that one. And notice when we add these up, 1 plus 3 is 4, plus 3 is 7, plus 1 is 8. So if you add them up, they add up to 8 over 8, or 1. So 100%. That's because we included everything in the sample space, so everything is there. The next thing, and remember, this is a probability distribution we're talking about. First, we list all the outcomes we could get. Second, we make a summary table. What's the probability of each of those outcomes? Third, we create a histogram. Right? Remember histograms? So all tails was 1/8. 1 tail was 3/8. 2 tails was 3/8. And all tails was 1/8. And we got this, we can count them in our sample space. Okay, and also notice they add up to 1. If they don't add up to 1, we know something is different. Let's put a note. If they don't add up to 1, it is not a probability distribution. Okay, so these are probability distributions. We know that probability adds up to 100%, right? So we make a little histogram. We're going to put the probability, right, and the value. So we use the value of 0, 1, 2, and 3. And then we have probabilities broken into 1/8. We'll put 2/8, 3/8, 4/8. We know we don't need to go that big because nothing got that big. So 0 had a probability of 1/8. 1 had a probability of 3/8. 2 was also 3/8. And 3 was 1/8. So notice for our histogram, right, the boxes have to touch each other and they all have to be the same width across as best you can, right? And we're talking here about random variables, and those take on numerical values that describe the outcomes of a random phenomenon. They're called random because the results are random. When you flip a coin, it's random. It could be heads, it could be tails. So those are random variables. Does that make sense? Okay, so again, this probably isn't new. I promise we'll get some new stuff in a little bit of lesson here. So let's turn our page and we're going to look at this example. This has to do with the Apgar test. So pause the video. You can read it here or you can print it off. All of these notes, you don't have to print them off. You can just write them on notebook paper, or you can just print the pages you need. There's many in here where I've printed things for us to read, so you don't have to print those out. You can just pause the video and read those. Okay, so pause the video. I'm going to stop it here to remind you. There we go. Hopefully you took time to look at that. This is kind of cool. You can ask your mom or dad what your Apgar score was. See, we've been testing you since birth. This is really cool, and we'll look at something with it in a little while. But if you notice the histogram here, very, very few babies, and then the bulk of babies are right up here. Okay, so that tells us we have a greater percentage of babies, that's healthy babies, that are right there. But again, read over this, check on your Apgar score. I would love to hear about what those are when we get a chance to talk. Another thing I want to look at, and I'm bummed out that we're not together in class so we can play this, but if you want to pull a roulette wheel up on your computer or your phone, you can kind of play. And one thing that I'll give you time to read this. One thing I want you to do is see that it's not fair. There's a red and there's black, and there's also two green ones. So when you look at these, the green ones, which are the 0, 0, and the 0, you don't get to win with those. So that puts you at a high advantage, the house at a high advantage, and they're going to win. So this brings us to a good, again, pause the video and read this, and even take your phone out and download a roulette wheel and play for a little bit and see how you win. If we were in class, we'd be doing that together. And we may get together in Google as a class and play for a little bit. But one thing that we want to bring out is the vocabulary word of expected value. So this is where we figure out mathematically right, what will happen in the long run. Remember, probability is always in the long run. You can flip a coin 5 times and get heads each time, but if you go into the long run, it's going to come out to 50-50, right? So in the real world, casinos do much better than what the expected value suggests. It's always in the favor of the house, I promise. With the roulette wheel, with this specific example, it's because of those green spots. So read that and see. But I want to show you what the expected value is. So we take the amount times the probability that you're going to get it, and we add all those up. Okay, so kind of like the first number times its probability plus the second number times its probability plus the third number times its probability, all the way down till we get to the end. And then we add those up, and that gives us the probability. Okay, so look over that, have a little bit of fun, and I'm going to go, and we'll come back and start with this tomorrow. Have a great afternoon.